Number 15, this one's very similar to number 14. We're given a contextual situation and we need to create a linear equation. In this case it doesn't use the word linear, but it's going to be a linear equation. We have a rate of change, just like we did in the last problem. So in this case, teachers earn a base salary of $57,500 plus $3,500 for each extra class they teach. So that extra amount changes based on the number of classes they teach. So we could let x equal number of extra classes. Okay, so we have 3,500 is the rate of change. As x changes by 1, the total salary changes by 3,500. So that's our rate of change. Rate of change is slope. The base salary is what the teacher makes if he or she teaches 0 extra classes. So that 57,500, that's our y-intercept, or our b. Part A, write an equation representing the teacher's salary. Well, for this one we could say y, total salary, is equal to mx plus b. M is 3,500, so m x plus, and b is 57,500 plus b. What is the y-intercept of the equation, and what does it mean in the context of the problem? So again, b is the y-intercept, or if we express it as a point, 0, 57,500. So in the context of this problem, the teacher earns 57,500 for the year if he or she teaches 0 extra classes. For part C, how much would the teacher make if they worked 3 extra classes? So remember, x is the number of extra classes. So in this case, we're given a value for x, and we need, what is y? Now we have an equation from part A. We could take 3 and plug it in for x. So y is equal to 3,500 times 3 plus 57,500. And if we pop that into the calculator, we will get $68,000. Part D, if a teacher made $64,500 for a given school year, how many extra classes did he or she work? Just to make sure, if you're given a number, make sure you're attaching it to the right variable. In part C, number of classes is x. In part D, total salary is y. So in this case, we are given the y value, we don't know the x value. How many extra classes? What is x? So if we plug 64,500 into y in our equation from part A, so that equation is the relationship between x and y. If you know one, you plug it into that relationship, you could solve for the other one. So 64,500, that's the y value, is equal to 3,500x plus 57,500. And now solve the equation for x. Subtract 57,500 from both sides. So we'll have 7,000 equals 3,500x. And if we divide both sides of the equation by 3,500, we'll get x is equal to 2 classes. So remember, for parts C and D, it's the same type of problem. We have a relationship between these two variables that's given by this equation. An equation in two variables is a relationship between the two variables. It's how the x's are paired up with the y's, or vice versa. So in part C, we're given an x, we use that equation to find the y. In part D, we're given the y, we use that equation to find x. As long as you know the value of one variable, you could always find the value of the other.